there, it's Teresa here. Thank you so much for joining us. My name is Teresa Younkin. I'm a healthcare informaticist. What that means is that I speak the language of the business and I speak the language of IT, and I try to bridge the gap between the two for us to create products that are going to benefit our end users. And in healthcare, that's our patients and our members. We're going to talk today about AI agents. You may have heard about AI agents, how they're coming to take over the world over the past 3 or 4 months, but in reality, they're really just separate functions of an AI model that work together to put the automations that you're looking for on steroids. Today, we're going to be talking about 5 different agents that you may run into. It doesn't matter. Well, understanding AI agents in healthcare, it shows you how technology is being used to enhance care delivery, make more precise diagnoses, and efficiently manage patient data. These agents, they're going to help healthcare providers like nurses and doctors to focus more on the patient interaction and less on those routine tasks. Like we always say, we want everybody working at the top of their license. One way to explain what an agent is, and I'm sure that you've heard about agents, they were like the rage and the talk on everybody's tongue about 3 months ago. Agents are specific AI routines that run, and they're very specialized. They do one task. Much like we used to talk about having personalized medicine, I remember back in the early 2010s when people talked about your specialist is going to focus on your eyeball, and then you'll have another specialist that will only deal with the pupil and a different one that would only deal with your retinas. Well, agents are kind of like that. We want to think about it in terms of the human brain as an AI system. So there are many different parts of your brain, right? You've got your brainstem, the hippocampus, you've got your frontal lobe, you've got things like the neuroplasticity in your brain. Well, you can look at AI agents, they function in almost the same way. So I'm going to use this whole brain talk as an analogy for how these agents actually work. The first are simple reflex agents. Your brainstem handles all the automatic reflexes like blinking if somebody comes close to your eye, or breathing. That's why you can't hold your breath. Even if you're going to pass out, you're automatically going to breathe. It's that autonomous system. AI agents, they also automatically respond to stimuli. So they operate on the basic if this, then that. And it mirrors a lot of our instinctual reactions that don't require any deep thought or memory. These agents react to immediate data. For example, if you're having AI monitoring, it might automatically adjust an oxygen level for a patient based on real-time sensor data. The second kind of agent is a model-based reflex agent. That's kind of like our hippocampus and memory integration. And the hippocampus, it plays a crucial role in forming and organizing, storing memories. And that helps us to predict and interpret new situations based on our past experiences. Model-based reflex agents, they also use a built-in model of their environment, and they'll incorporate past data to make decisions. It's like having a mental map that guides your responses more intelligently than just a simple knee-jerk reaction. These agents have a built-in model of their environment, which they use to make informed decisions. In healthcare, an AI that is using a model-based reflex agent, it might predict patient risks by actually considering both the current vital statistics and past medical history. The third type of agent is a goal-based agent. That's similar to your frontal lobe and planning functions. Your frontal lobe, it's critical for complex behaviors like planning, decision-making, and it enables us to evaluate future scenarios before we act. Now, goal-based AI agents, they do the same type of function. They plan their actions based on future goals and outcomes. They consider what could happen next. Much like we plan steps to achieve long-term objectives, these agents, they're all about achieving specific health outcomes. One example would be an AI that's designed for a rehab program, and they design rehab plans and activities and therapies that are going to be tailored to meet each patient's recovery goals. Number 4 are the utility-based agents. Now, these are exciting because these are like our reward system. And when I say reward system, I mean our dopamine-driven decisions that we make. So our brain's reward system, well, it evaluates our actions based on potential pleasure or satisfaction. That's why we don't like to do hard things. It doesn't bring us pleasure, but we do it because we know in the end we're going to get some satisfaction out of it. Well, when we're dealing with these dopamine driven decisions, these guide us towards behaviors that maximize our overall happiness or the utility. Now, utility-based agents, they also operate on a similar principle. They assess which actions yield the highest benefits or satisfaction, just like our brains are calculating which decisions will make us feel the best. These AIs, they prioritize actions based on overall well-being or satisfaction. In healthcare, that could mean that you design an AI system that's going to decide among treatment options based on which is most likely to improve a patient's quality of life. And number 5, the last type of agent is called a learning agent. That's like the neuroplasticity in our brain. Neuroplasticity refers to the brain's ability to adapt and to learn from new experiences. So it changes its structure and the functions in response to new information, new environments, and neural processes. Now, our AI agents, they can mirror this adaptability because they learn from past actions. They can adjust their strategies and they can improve their performance based on continuous feedback. Just like our brains refine our skills through repeated practice and learning. So that's why we drill. Think about Kobe Bryant. He was out there shooting baskets all the time. He was doing it to learn the skill through repeated practice and learning. In AI, these are adaptable. They are constantly improving from past actions. The AI that you could build would be one that could help manage a chronic disease. It might learn from your previous treatment outcomes, and that would help it to better tailor future care plans. Think about the different ways that these agents can work together, how systems adapt, and how they respond to the environments. When they do that, they optimize function and decision making. If the information that's being put into our brains isn't the right information, we don't have the most optimal outcomes. You know what? AI is the same. If we're giving it good data and feeding it in a way that it's nourishing to the AI, meaning good data, we're going to have great functioning AI brains. So as we leave today, think about the different types of agents. Make sure you're using the right agent for the right project. These agents can be chained together to do more than one thing, but let's focus on one simple task at a time. Let's get good at it, and then let's start adding others. So, thank you for joining me. I appreciate your time, your energy, and all that you do. I'll catch you guys here again next week, where we're going to be having another conversation about healthcare, AI, and technology.